Okay, so I wanted to talk about the ether. And the ether itself is isentropic and homogeneous. What does these terms mean? Because homogeneity, I don't know if I said it right, but the homogeneous means that we have a substance that has the same properties everywhere. So a homogeneous would be, for instance, a gas of hydrogen filled with only hydrogen atoms. It's also isentropic. So what does that mean? That means that in all directions everything stays the same. It's a basic fluid. There are no exceptions. Everywhere the same properties occur. So density is everywhere the same, and if you move a particle, the forces for the particle would be the same. So everywhere in the fluid the same rules apply. The ether would be a perfect liquid, a perfect gas, an ideal gas. And what does it mean to have an ideal gas? An ideal gas would be that the temperature of the gas would be only a function of the internal energy. It does not depend on its volume. So there is no expansion or compression of the fluid because of temperature. So temperature is not an issue in the ether physics. Well, it is, but it has no effect on the ether itself. Temperature is something that's happening with the ether that has effect on other parts of the ether, even though the density within the ether and the pressure would stay the same. And what I wanted to talk about was the main idea of an atom. I haven't quite explained my idea of the atom in ether physics. We're gonna try and explain it a little bit better. We start off with the core of an atom. We're gonna try and build a hydrogen atom. What I'm gonna do is explain the hydrogen atom within space, within the absolute ether. Imagine the board being full of particles of ether. I'm not gonna draw them all because that will be a lot of work. In the middle, we're gonna create one hydrogen atom. So that means that the particles of ether on the board are all having the same density, so they're everywhere the same amount of particles of ether within, for instance, a cubic centimeter or cubic inch. Or it would always be the same amount of particles of ether in the absolute free space. There is a flow, and we've talked about vortices before and about the core vortex and the irrotational vortex around the core. So what I believe that is happening is that in the fluid, in the ether, we have, I'm gonna try and draw this correct, and I kinda did. Yeah, we have a trefoil nut. It would have 3 quarks in it, 2 up quarks and a down quark, and that's possible. That's possible with the trefoil nut, because the trefoil nut has some interesting properties when we're talking about flow. So this would be the core vortex. So let me draw again. Last drawing, the core vortex, just a small part of it. We've seen this before, it's the core, and this line would represent the core. What happens is this core would roll, for instance, in one direction. So it's rolling around its core. So within the core, we said we had a lot of vortex lines, and these vortex lines are just particles stacked on top of each other that have the same vorticity factor. And that means that all the particles that are in line on top of each other in the vortex, in the trefoil nut, will stay inside the trefoil nut and would not exit. It won't exit because of the pressure of all the particles around it. And because of the rotation, the vortex lines try to expand, because that's what happens when something rotates. It tries to expand itself, but it can't because of the density of all the particles around it. So it stays inside the vortex. It won't leave the vortex. The energy stays inside. It will just keep on rolling. And what actually happens is that around this trefoil nut, around this core vortex, there is a flow as well. So that means that around here we get ourselves another flow of ether. So And as you can see, this starts to look like a vortex ring a little bit. It is not, but it looks a lot like a vortex ring. What also happens is because it is folded, this trefoil knot, it starts to rotate around its center. So I'm going to draw a center line. And what I think that is going to happen is that we have here a rotation. And there. So we have a line all through the center with rotation. And we can think of this particle in two ways. We can think of the particle standing still. So and we call this a particle, this trefoil knot. And if we imagine that the free curvature, free curves at the end, if they stand still in their position, we would think that the center of the vortex would be rotating. If we would say that the center is not rotating, so we're saying the center stands still, nothing is happening, that would mean that these lines would start rotating compared to the central line. And that's one of the things that so this is one of the things I'm trying to teach you guys, is that there is a rotation, and it depends on how you look at it. You can see it as if the middle line would be rotating, then you would say that the background free space would be rotating, or you can say that the background free space would be standing still and that the vortex is rotating. And I think that this rotation that we have would be the charge of the proton, because what happens is because of its rotation, it will get another rotation, or it will let the ether flow around it rotate as well. This drawing is not to scale, of course. This is just an idea of what I think that is happening. What does this mean? This will be an irrotational flow. This will be a rotational flow. Well, not this entire thing, but the vortex itself will be rotational. Around this core, I expect, when it has a rotation, that we would find a certain point, a spherical point of equality in pressure. It would look as if there would be a sphere around the center. So I'm going to try and draw a sphere a little bit. So this will be the sphere. And this sphere would look as if it is rotating in one direction. Because it looks like it's rotating in one direction, we would say that it is a charged particle. And this rotation would mean it is charged. If it has no charge, if it has no rotation, but it still has inertia, then that would mean that the core vortex is not rotating around its center. But it's just an idea. I'm still working on my idea. We got ourselves a atom rotation, maybe we can call it that, or core rotation. No, it's not core rotation, because that's the core and it's rotating. And we call this circle, we call that a particle. Even though it's not really a particle, it's a flow of particles that has a pressure equality eventually with its surroundings. Okay, so what happens around this particle? Because this has a torus kind of flow as well as it is rotating, we can see different huge circles for toroid flow. I don't know if it's the right word, the toroid flow, but I'm not going to use that word because it's a torus. This flow around it would have certain points in flow that have the least amount of pressure. Least or maximum, I'm not quite sure. I haven't figured that out. But these points would represent the positions most likely to find the electrons of atoms. I drew 4 points, but this will be connected, of course, in a spherical manner. So we can find our electron somewhere here or somewhere there. And what is the electron itself. The electron itself is also an ether flow. The electron, we have a wave-particle duality with electrons. And what does that even mean? What does it mean to have a wave or a particle, or to have both? When is a particle a particle? Because I think that whenever physicists talk about particles, they talk about vortex knots. This will be the first stable vortex knot, but we can make different kind of vortex knots. What I think, and I'm not quite sure, but I think that electrons and photons are both flows of ether. Without the interaction of an electron and a photon, they would both just look like simple vortex rings. This ring would roll in a certain direction, so it would look as if it is a circle. If we would check it from the side, it would look like a rolling ring vortex. And I think the photon is the same, so photon would be another ring vortex in a certain direction. As long as these two are not connecting, we would have our wave-particle duality. When would this actually look like a particle with inertia, so that it has actually mass? And I think that happens when these two connect to each other. So whenever we have, and I'm going to draw this a little bit simpler, so we just say this is a circle form and that will be a circle form, that whenever these two connect, that they would look like this, so that these circles interconnect, and whenever they interconnect, they start rotating again, and whenever it starts rotating, it has inertia, and when it has inertia, we would call it mass. I think that is all for today. Yeah, I hope you enjoyed this video, and if you did enjoy this video and you watch this on a regular basis, be sure to subscribe. Well, it will be cool if you subscribe. I don't even have to tell you yet to subscribe, because you know how to subscribe and stuff. So thanks a lot for watching, and see you next time.